Good afternoon, viewers. Welcome to this session. The topic for our discussion today is file handling in C programming. So, till now we had seen the basic components of the C programming, the control statements, arrays, functions in C programming, then structures in C programming, pointers in C programming. Now we will see another important topic, that is file handling in C programming. I am Professor Subrahmanyam, Director, School of Computer Information Sciences, taking you to this particular session on file handling in C programming. So this particular topic, as I told you, is very important in the sense that it will be helpful for your MCS 011 as well as MCS 021, that is data structures. Then it is also very much useful for your analysis of algorithms, that is in the third semester of MCA. So till now, whenever we are giving the inputs for the program while running after compilation, so we are providing it through the program, or else we are asking the user to key in the data. The prompt is through the printf statement in C programming that enter two numbers, and afterwards in order to scan those two values we will write scanf function, and then the program will obviously act upon the values that the user has presented, and then later on the program will keep on running, and then the required the output will be produced. So this is for the small programs. Suppose in the commercial practice, what else you require? User may not be prompted to enter the values, the inputs. However, it will be taken from a file, that is the source file. So it is very much necessary to keep the data in a permanent storage, that is the hard drive. So suppose if you take the case of structures programming, in that programming we had discussed 2 or 3 important examples, that is an employee structure meant in later on to calculate the pay and other welfare of the employees. And in the second example we had seen the student data, the student structures, wherein which later on in the part of the program the marks calculation, the print of the total, then average and the grade. So for these kinds of things, huge records are the input sources. Like a class may contain 60 students, wherein which there may be 5 subjects, and then 60 into 5, there will be several records including the name, enrollment number and the other accessory things. So these can't be given by a user upon a prompt. So which is the best method? So it may be available, it may be made available in the form of a file. So here comes the file concept. So the data to feed into the program will be from the source file. So obviously all those records will be scanned, and then necessary output may be appearing on the screen or else on the printer. So it would be very much difficult, as you might be understanding by this time, it will be very difficult to handle large volume of data that is needed by the programs, and after the execution of the program it may be a process wherein which the screen may not be sufficient, the single display of the screen may not be sufficient and it may scroll down. So we may be in a position to divert that output also into a separate file, that is the output file, which may be taken the printout in a later on time, or else the source, the inputs coming from a source file after the calculations are done by the program may be diverted to a printer to print the output values. So C supports the concept of file through which the data can be stored in the disk or secondary storage device. So separate files will be maintained for the inputs, wherein which the program will pick up the file, take the source inputs, execute and displays the output. So normally a file is a collection of data or text placed on the disk. So it will be identified with a name dot extension file name. So a sequential, other definition we can provide here is, it is a sequential stream of bytes ending with a end of file marker. So the start of the file and then there will be a end of file marker, EOF, end of the file marker. So that is the delimiter for a C file. So till then the bytes will be streamed and the end of the file will be EOF. So when the file is opened, the stream is associated with the file, whether we want to input some values into the file or else whether we want to read some values from the file. So both the things are possible. Appending is possible. Let us see in the due course of time what all the operations can be done using these files. So by default, these three files and their streams are automatically opened when the program execution begins. That is, first one is the standard input stream, second one is the standard output stream and the standard errors stream. So whenever the file is opened, all these three program executions begin. The standard input stream begins, output stream begins, the standard error also will begins. So C will support two types of files. One is the text file and other is the binary file. So these particular text files, as we can see, everything is stored in terms of text, and the binary, it is in the zeros and ones. So for each and every line, you may be seeing in the program that a new line character will be there. That is the end of line. But for the end of file, it is EOF. So text file, it is nothing but the whole items are the text items, and then a binary file contains data that was written in the same format, but it is not in the form of text, however in the form of binary values, that is zeros and ones. So how to work with files? Let us start. First of all, the declaration part is very much important. So how to declare in order to use a file or in order to create a file in our program? So that is important. So the declaration goes in such a way that file is the keyword, that is a pointer star fptr. Here for example, I had taken a pointer variable as fptr. That itself is telling the program that fptr is a pointer variable which points to a file. In the earlier class, we had seen the pointers. So in order to point to an integer, you wrote int star ptr, wherein which ptr is the pointer variable which points to a int, or else ptr is a pointer variable which is storing an integer values address. So here you can see the difference. We are using a term or else a keyword called as file. So fptr is a pointer variable which is pointing towards a file. So when working with files, you need to declare a pointer of type file. That thing you have to remember. As and when you require many files to work with, all those things needs to have a file pointer. Suppose file, suppose if you want to work with 3 files, then you declare 3 file pointer variables file star f1 comma star f2 comma star f3. F1 pointing to the first file, then F2 pointing to the second, as well F3 pointing to the third. So this declaration, you must understand, is needed for communication between the file and the program. So this is must. In the declaration part, whenever you declare the variables, whenever you declare the structures, whenever you declare the functions, then itself the first part you have to declare the files whenever you want to use them during your course of programming. Then the possible file operations on this particular files are, one is creating a file. Suppose if you don't have a file, you can create a file and then you can input the values in the file or else records in the file and then close the file. So first thing is creating a file, opening an existing file, that is already one file exists and we want to read or write or append. So all these file operations are possible. Then reading from a file, writing to a file, moving to a specific location in a file, that is we want to hit some point or else location in an existing file, that is also possible, and then closing a file. So all these file operations are possible during our programming. Then how to open a file? So there are several functions associated with these file operations. One by one we will see, like how to create a file, how to store a file, how to read a file, how to rewind a file. All these things contains the ready-made inbuilt functions, and what exactly are the syntax that we have to follow, that we will see in the due course of time. First of all, we will concentrate on how to open a file. So opening a file is performed using the fileopen function. So you can see here fopen, that is the function you have to write in order to open a file. So what else you have to write? The exact syntax is, so file, you will be declaring a file pointer for that file, and that particular pointer is equal to, then write fopen function with the arguments within double quotes, file to be opened and then mode. You can see two arguments are must. The first argument is in order to specify the location, and the second argument is to mention the mode. What are modes? Read is a mode, write is a mode, append is a mode. So these are the three modes. Like whether if you want to read only the inputs from the file, then you have to select the mode as R. Whether you have to write something into the file, you have to open the file in write mode, WRITE, that is write mode. Suppose if you want to append the contents from the end, earlier it was some EOF is there, so from that point onwards if you want to append the contents, you have to use append mode. So you can see the example here, fopen, within the double quotes you had mentioned the complete address along with the file name, and then the second argument here we are passing is the write mode, WRIT, write mode. So file opening modes, as I told you, one is R mode, that is read mode, the second is write mode, and then the third one is A, that is append mode. So when you select the R as the second argument, it searches the file. If the file is opened successfully, then it is loaded to the memory, sets up the pointer declaration, that is file star ptr or star fptr, whatever you are mentioning in the declaration part, that particular pointer will be set up as a pointer which points to the first character in the file. And then what else? End of file is the delimiter to that particular file. If the file cannot be opened, then it searches the file. You have to put the mode as W within double quotes as the second argument. If the file exists, its contents are overwritten. If the file doesn't exist, a new file is created and then returns null if unable to open the file. Then another mode that we will discuss is the append mode. So earlier write means it is overwriting. So append means it will continue from the end that was existing earlier. So it searches, whenever we put the second argument as A, it searches the file. If the file is opened successfully, fopen loads it into memory and sets up the pointer that points to the last character in it. So because we are here using the append means it continues from the end point earlier existing. So if the file doesn't exist, a new file is created and returns null if unable to open the file. So what else are the modes we can have? Those are R plus. If is opened successfully, fopen loads it into the memory and sets up a pointer which points to the first character in it. Returns null if unable to open the file. Then there is W plus and then A plus. So these are the 6 variety of modes that we can insert as the second argument in the fileopen function. Next, coming to the binary files, those are meant for text files. And even if you see here, you can write RT also within double quotes, RT also. By default, if you write R, it will take the text file as the by default file. If you write RT also, the same thing will happen. But in case of binary file, you have to specify, here you can see, you have to specify WB. Within double quotes, whenever you want to have a binary file as an input, or else whenever you want to read a binary file or write a binary file or append something to the binary file, obviously you have to include one character called as B in the along with the mode at the second argument of the fileopen function. So W itself mentions a text, right? That is mode for a text, write mode for a text. But when you work with a binary file, you should write WB. Compulsorily you should write WB within the double quotes as the second argument for the fileopen function. You can see here a simple example. FP is the file pointer. FP is equal to fileopen within braces, within double quotes. The first argument is the file name data.dat, and then here you can see, in order to specify the data.dat is a binary file, that too you want to open it in the write mode. So second argument is WB. So write binary. Then for read also you can see the example RB, that is must, you have to write B along with the mode. And then coming to the AB, this is for the append. FP is equal to fileopen data.dat, and here you can see AB, that is append binary. So compulsorily you have to write the B. Likewise R plus B, and likewise R plus, that is read plus, and write plus also you have to use R plus B. B you have to append at the end, that is postfix, and W plus B, that is also for write plus also you have to include the B. So here you can see the simple example. It is a simple example. Star FPTR is a pointer variable which is pointing to a file structure. FPTR is equal to fileopen, within braces 2 arguments are passed. One is the file name, that is abc.txt, and then as we are opening .txt, so either you may write WT or else W itself is enough. Suppose if you want to work with a binary file, you could have written WB. That thing you have to remember. Then whenever you open a file, one file, or else if at all you are working with one or more files, obviously towards the end of the C program you have to close the files. Whatever the files you had worked with, like one or many, So all the files need to be closed with a function called as fclose. So both the files, either it may be a text or binary, the good practice of C programming obviously is when you open a file, you should close that file towards the end. The file should be closed after reading or writing or even appending also. Closing a file is performed using the fclose function. You can see the syntax over here. You have to write fclose and within the braces, a file pointer needs to be written. Like suppose f1, f2, f3 are three file pointers that we had declared at the earlier stage and we had worked during the programming part. So obviously the last three statements before the end of the program would be fclose within braces f1, then semicolon, then the last before statement will be fclose within braces f2 semicolon, fclose within braces f3 semicolon. So all these files needs to be closed if at all we are working with the three files in our program. So here you can see in the example fptr is a file pointer associated with the file to be closed, that needs to be mentioned. So this function, this fclose function flushes any unwritten data for stream and then discards any unread buffer input, frees any automatically allocated buffer and then closes the stream. So the streams, as we had seen, the standard input stream, standard output stream and then standard error stream, all these streams will be freed and then closed along with this statement, fclose statement. The return value is 0 if the file is closed successfully, otherwise if it is having any kind of error it will be displayed. And then obviously what is the file marker? EOF is the file marker for any file. So for F1 also EOF will be there, that is the delimiter of the file that we are about to close. Let us see a simple program. Here a simple caution statement is written. If at all the file is opened successfully, then you can see the else part for processing. Otherwise you can see the if part. If fp, which is the pointer variable to a file, if we are opening that file in the read mode is equal to null, then file doesn't exist. That is the simple statement that we had written in the if statement. Exit on 0, else if it successfully opened, then some processes will be continued, and you can see that file pointer fp we are closing before the main program close, fclose within braces we had written the fp. So this particular practice you have to look into while working with files. Whenever you open the file in read, write or append mode, all those files should be closed at towards the end of the program. Then comes the input output using the file pointers. So till now we had seen some printf statements, scanf statements which we were using during our simple programs. In order to tell something to the user, we incorporate certain labels or else a kind of simple statements within double quotes, enter two numbers or else enter the value of a comma b comma c. So in this way we try to communicate to the user, and whatever the values that the user gives after looking into the message that is passed, those will be scanned or else those will be taken as the inputs and the programs will later on execute. So here also, if at all certain formats are required or else certain characters needs to be taken as inputs or strings directly can be taken as the input, or else formatted input output functions may be taken as the input output using these file pointers, or else some continued block also can be taken as the input output function. So associated with these four kinds of functions, we can see the associated ready-madely inbuilt functions that we can obviously take and work with them in our C programming. Suppose in order to scan a character, or else in order to read a character, or else in order to write a character to a file, or else in order to read a character from a file, there are certain functions available. What are those functions? We will see. Likewise, the complete string can be read using a file function. Likewise, you can put some complete string into a file, or else insert a complete string into a file. So let us see what are the functions those are available in order to play with these all 4 kinds of formatted things. So here you can see 2 functions we had mentioned. One is getC, putC. That is get character, put character. Get character is nothing but it is used to read a character from the file. So getC is that one. And then in order to write the character into the file, then we will use the putC. And then you can see the syntax over here. putC, int putC, within brackets there are 2 arguments, int ch comma file pointer, and then int getC also directly file pointer, file star stream. So let us see some examples in this program. Include this main program is it consists of 2 file pointers, those are fp1, fp2. So a caution statement is written over there. If at all there is no file, error opening the input file. If at all it exists, then here you can see if fp2 is equal to fileopen, one file is there, that too we are opening it, and both the files we are just checking the statements. And then if at all the files are available, then it comes out and then it will execute from the while statement. Otherwise, it will display the message error opening input file or error opening the output file. So this program is meant to take one character from file 1 and write the same character into a new file, that is fp2, that is file 2. So this is a simple program which copies the contents of one file into the contents of one file and stores it into a second file. So the first if statement you can see here, those are the caution kind of thing, wherein which if at all the file is not open, appropriate messages we are displaying. Error opening file input file f1 or error opening in output file f2. Suppose if that is qualified and it is coming to the else statement, while end of file, that is till end of file marker is encountered for fp1, that is file 1, what all needs to be done? Get the character one by one and put the character in fp2, that is file 2. We are getting character by character from file 1 and we are writing the character by character, same character by character in file 2. You can see here, please concentrate on the while statement. While ch is equal to, that is we are capturing character by character using the function getC from file 1, and the next function is we are writing the same character whatever that is fetched from file 1 into file 2. So this is a simple program, and after copying all the contents from file 1 to file 2, you can see the last statements, we are closing the first file as well as we are closing the second file. So this is a good practice of C programming whenever we are working with the file concept. So then the second thing is how to work with the strings. Suppose if strings are there and if we want to capture the complete string, how to read the complete string from a file, or else how to write a complete string into the file. So earlier we had seen only character by character, and here we are playing with the strings. If we want to read a whole line in the file, then each time we will need to call a character function, that is character by character. It will be a very difficult process. Suppose if you can capture the whole line at one go, that will be very much convenient for you, and also the execution speed will be increased and the performance will be increased. So instead it has some IO functions, those are fgets and then fputs. Like you have get C, put C, here you have two functions fgets and the second function in order to write is fputs. Syntax you can see here, as we have the syntax for get C, put C, here also for fput S, fget S, you have the syntax. So there is a demo program here. The first if statement is very simple. This program is to read a file and count the number of lines in the file. So what is the delimiter for a line? That is new line character. So till then you can count it as a line. Suppose if it consists of 80 lines in a file, then like 80 characters in a file, so that particular thing, each and every line can be captured with a delimiter, that is end line character. So as you can see, fp is a file pointer over here, and we are initializing the counter with 0 value, and then the character string of which is been assigned as 80. So we are trying to open the file in a read mode. Why? We have to read, we have to check, and then we have to display the number of lines in that file. So no need of writing. So we are just opening the file in the read mode using the file pointer fp, and the first statement is the check statement, like if at all the file exists or not exists. If it doesn't exist, appropriate printf command we had given over there. If at all it exists, look here, we had written a while statement, while end of file, that is file end of file within brackets fp till end of file, fgets, here reading string str comma 80 comma fp. It reads at most 80 characters in the string, that is the upper limit that we had given in a line, for a line. And then for each and every encounter of that fp file end of file, increment the counter of reading every line, and then at last we are displaying the count of number of lines. So this particular program is to read a file and count the number of lines in a file. So here we had opened the file using only read statement, there is nothing to write. So we had opened this particular file using the file pointer fp in read mode. We had checked for the condition whether the file exists or not exists. If at all it exists, we are using the fgets in order to capture the whole string that is existing in the line, and then we are incrementing the counter whenever the new line is appearing, and then it ends with the display of number of lines in the file of that particular fp. Then comes the third kind of thing, that is formatted input and output functions. So if the file contains the data in the form of digits or else float values, characters, strings in a formatted kind of thing, so better use fprintf and fscanf as the file functions. So there are two functions available for the formatted input output functions, those are fprintf and fscanf. So with this particular two functions, whether if at all you want to print something into the file, so you have to use fprintf. If at all you want to read the formatted form of digits or float values, you can use the fscanf. So the syntax remains int fscanf. You can see two or more arguments are there depending upon the format that is being read or write. Both these functions return an integer indicating the number of bytes actually read or written. So this is an integer. We are declaring at the top you can see, and then these functions return integer indicating the number of bytes. Those are read for scanf, fscanf, and return for fprintf. So this is a simple program which opens a bank, like one file is available, like bank.data, that is available on your hard disk, and we are opening it in the read mode, and then it will read all the records, and wherever the account balance is 0, so those records will be printed. Suppose if a person's, there are 100 records and only 2 records are having the balance of 2, those 2 records will be printed. So here you can see the first are the cautious statements and then fscanf. So complete scanf is here, you can see fscanf do within brackets fscanf, that is we are scanning in the formatted output. Like within the file there are 3 records, 3 fields. One is the account number field, second one is the name field, and third one is the balance field, which are existing in the same line as a record in a file. So that particular 3 records we are saying, and what we have to check, which thing we have to check again is the balance. If at all the balance is 0, you can see here in the next statement, if at all the balance is 0 for the record that we are searching for, then it should count the value. So or else it should display the whole record. Wherever it encounters the balance is equal to 0, the complete record along with the account, name and balance will be displayed as the output for this program. Then comes, suppose not line by line or not the formatted kind of input like real numbers or else characters, like kind of thing. Suppose if you want to read the complete block, that is we will be indicating the start point and the end point within the file, and then if at all we treat those particular delimits as a block. So how to read them? There are 2 functions available, that is fread and then fwrite. A block can be a record or else even set of records also, or else an array, whatever the case may be. That is up to you. You call it a simple record as a block or else a set of records as a block. That is up to the user to make a note. And then the functions you have to read in order to take the block as the input, the function is fread, and in order to write block as the block into the file, then you have a function called as fwrite. This is a syntax that you have to use: void pointer variable buffer, integer number of bytes, count, then file value. What all these particular arguments points to? Let us read. In case of fread, buffer is the pointer to a memory area that receives the data from the file. So it is marking certain area, the kind of buffer. Then fwrite, it is a pointer to the information to be written onto the file. Number of bytes, you can see here the second argument, int number of bytes. That number of bytes specifies the number of bytes to be read or written. So that we can call it as a block. These functions are quite helpful in case of binary files. These are normally used in order to access the binary files. Generally these functions are used to read, write arrays of records, that too whatever those are there in the binary form. So coming to the file access. So till now, till this point of discussion, we are assuming that everything is in a sequential fashion. We are starting right from the point, the file pointer, that is the start of the file pointer, that is the start of the file, and then we are going till end of the file in a sequential way. So till now we are assuming that only sequential access is possible, which is untrue. So there may be a sequential access which can be done, obviously whatever we had seen, and there may be a random access kind of thing also possible in C programming. So sequential access files allows reading the data from the file in a sequential manner right from the start till it meets the end of file marker, which means that the data can only be read in a sequence. Suppose if you want to go to a particular point, that is a random kind of thing, that is also possible. So for that we have certain functions. One function is fseek. This is used to set the file position. So to from which point you have to read or write. That fseek is the function we have to set in order to set the position in the available file. So here it consists of 3 arguments. The first argument is the pointer to a file, whatever the file that we are trying to read or write. The second argument is the number of bytes to move the file pointer counting from 0, that is right from the start position to reach to the position that we want. Either it can be moved in a positive direction, it is in the progressive way, or else whether we want to fetch the earlier values. So both the things are possible. So from count 0, the existing position, suppose if you treat it as a 0, either it can be positive by moving forward or negative by moving towards the backward from the existing line. So that is meant for the second argument. The third parameter is a flag indicating from where in the file the compute the offset. It can have 3 values, that is 0, 1 or 2. What exactly is the 0 indicates or 1 or 2? Suppose if you want to seek or else set to the 0th position, that is the beginning of the file indicates 0, the current position is 1 and the end of file is the value that can be given as 2. So here you can see file pointer we had understood, long offset we had seen that from the current position whether to progress or else to go back in the file, and then int pos that it will take either 0, 1 or 2. 0, 1 or 2 means either we have to go to the initial position or else from the current position or else to the end of the file. So these are some of the functions that you can use in order to handle the files in C programming. Before ending this session, let us recap. So in this particular session, what we had seen, we had defined a file. What is the purpose of a file? We had seen that in simple programs we can ask the values from the users and can execute the program using those values that are being inputted by the user and can display the values what all been calculated during the program execution. Suppose if you want to work with number of fields or else number of records or else huge data, the source should be a file which will reside on a hard disk or any secondary storage medium. So from those things we will capture the values from those source, that is the files we will capture, or else we will take the values into the programming, we will calculate, or else the program will be processing those particular data received from the file, and then it may write to a file or else it may write to a printer. So among which we had seen there are 2 types of files C can work with. One is the text file and the other is the binary file. And later on we had seen the formatted kind of things like for characters, for strings, for blocks, etc. And then we had seen how to access the files either in a sequential way or in a random way. If at all it is a random, what kind of function we can use, that is the fseek function we had seen with the 3 arguments. that too where to move, or how to set the values for the arguments that we had seen in the random file access. With this, I hope you understood the file handling in C programming. Practice the exercises that we had given in your chapter, file handling chapter. Go through the examples, work with the check your progress exercises that are being given in the file handling using C programming. If at all you have any doubts, please mail me on pgdca@ignou.ac.in. Before concluding, please, I'll once again request to go through all the 12 units that are there in your MCS 011, and then please try to do the foundation kind of foundation in this particular C programming very strong, so that it will be useful for you in the coming semesters, in the second, third, likewise. That too, in order to understand various programming languages, this is the base or foundation that is being laid down for you as the first course. So try to concentrate, try to do, try to practice, so that you will have a good command in programming using C language. With this, I'll conclude the session. Thanks for patiently listening to all these 6 sessions that we had come across. And in the next session, I will start MCS 041, the core course on operating systems. The students whoever are having the course MCS 022 also can listen to the session from next Saturday onwards. With this, I conclude MCS 011 and I will start MCS 41 or MCS 22 from the next session onwards. Thank you. Happy C programming.